In this lecture, we will talk about how to graph the rational functions. Here there are two functions. One is f of x equals 1 over x. Another is f of x equals 1 over x minus 3. Before we graph the picture, we want to find out the domain. In this case, probably it's easier because domain denominator cannot be 0. Okay, if denominator is 0, we don't know how to calculate 1 divided by 0. Okay, so another way of writing this is from negative infinity to 0. Here is round bracket, so 0 is not included, and then from 0 to positive infinity. That's the interval solution. Similarly, for this one, x cannot be 3. If x is 3, 3 minus 3, so you have a 0. Okay, yeah. So here you may do in algebraic way is x minus 3 cannot be 0. Both sides add 3. You cancel positive negative 3. Then you have x cannot be 3 because 0 plus 3 is 3. So you have that. And then the interval interpretation or solution will be from negative infinity to 3. Round bracket means 3 is not included, and then from 3 again 3 is not included with this round bracket to positive infinity. So that's the domain. Now let's look at how to graph the pictures. You know, for graphing the pictures, if you don't know how the picture looks like, then you need to choose the points. Okay, and then connect all the points with a smooth line. You see right here we start with x cannot be 0, so we start with negative 5, negative 2, 1, negative 0.5, negative 0.2. So you see negative 5, negative 2, negative 1, and then negative 0.5 is the middle point right here. Negative 2 and negative 0.2 is even close to 0. Okay, you have an x value here, you plug in, so 1 divided by negative 5 is negative 0.2. That's y. So x is negative 5, y is negative 0.2. You see from 0 to negative 0.2, very close to 0. So this point. And then negative 2 you plug in here. 1 divided by negative 2 is negative 0.5. So y, this value is negative 0.5. So negative 2, negative 0.5, negative 2 is here, negative 0.5 is right in the middle, so this point. Okay, the third pair is, well, x is negative 1. You plug in 1 divided by negative 1, you have a negative 1. So negative 1 here, negative 1 is on the point. Now here for x equals negative 0.5, you plug in here 1 divided by negative 0.5. You can use your calculator to find out that. Okay, but you know, negative 0.5 is actually 1 negative 1/2, and you flip these two up to the denominator. Here is more details for that. Okay, more details for that. You see 1 divided by negative 1/2, that's 1 times negative 2/1. Because you change the division to multiplication, you have to flip it, and then that's negative 2. Okay, so that's why here is the same, negative 2. Basically, you just flip these two up. If here were 3, that will be a little bit complicated. Here were 3, here were 3, here were 3, then 2 times negative 2 times 3, you would have negative 6. Okay, that's more complicated. Here we just have a 1 upstairs, so you flip this 2 up, you have a negative 2. Okay, so negative 0.5, negative 2, negative 0.5 is here for x, negative 2 is here, so would be this point. Now here negative 0.2, you plug in negative 0.2, 1 divided by negative 0.2, then you have 1 divided by negative 1/5. You know 0.2 is actually 1/5. You actually know that. You see 1/5 is 0.2. Okay, you flip this 1/5 up like this one we did here, so you have a negative 5. Then you have x equals negative 0.2, very close to 0. Y is even deeper down, negative 5. This is y. So this point, negative 0.2 and negative 5, is the one right here. And then you have 1, 2, 3, 4, 5 points. You connect it. Okay, you then have the left-hand side. Remember, x cannot be 0. Okay, you plug in, does not make sense. So x cannot be 0. So this line can be very close to y-axis, but never touch y-axis. From this direction, if you go to the negative infinity, this line can be very close to x-axis, but never touch x-axis. Okay, so here I didn't write it down. Basically, the range is x also cannot be, the y also cannot be 0 for the range. Yeah, if you want this whole thing be 0, numerator has to be 0. But you know, numerator is always no 0, it's 1. So then y can never be 0. That means this line can never touch x-axis. Okay. Now, similarly, you do for 5. 5 is right here. You plug in 5. 1/5 is 0.2. So 5.2 is right here. Okay. You do for 2. You plug in 2 here. 1/2 is 0.5. So when x is 2, y is 0.5. X is 2, y. This one is x. This one is y. This one is x. This one is y. Okay. So when x is 2, y is 0.5. X is 2, y is halfway 0.5. So this point is the second point. Now x is 1, you plug in 1 divided by 1, you have 1. Okay. So here you have 1, 1. X is 1, y is 1. So this third point. Now another 2 points. You have 0.5. You plug in here. 1/0.5 is actually 1/2. Flip 2 up. So you have a 0.52. Okay, 0.52. So 0.5 is for x, 2, y is 2. So 0.52 is right here. Okay. Now, if x is 0.2, you plug in 1 over 0.2 is 1 over 1/5. Flip 5 up, you have 5. So 0.2 is quite close. This is x, quite close to 0. And 5, that's y value right here. So you can connect all those 5 points. Okay? Then you will get the left-hand side of y-axis. Again, you can see right here, 1x goes to infinity, bigger and bigger. This curve will be very close to x-axis, never touch x-axis. Similarly, for x goes to 0 from the right-hand side, from the positive side, this line can be very close to y, but never touch y. Okay, because x cannot be 0. Then there is no corresponding y here. That's basically the picture, this one, for 1 over x. Actually here we chose 10 points. You see, 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5 points. Together 10 points. Okay, and here we call this x-axis is horizontal asymptote. If it's horizontal asymptote, y is 0. That's the equation. Similarly, y-axis is called vertical asymptote. In this case, x is 0 is the equation of y. Now, that's the graph, this one, for that.